So for section 4.1, we are looking at interpreting the meaning of what a derivative means. So remember, the derivative of a function can be interpreted as an instantaneous rate of change with respect to the independent variable. So they're giving you a function q of t. So remember, t is the variable in the function. That's the independent variable. So we talk about taking the derivative with respect to the independent variable. In this case, we're going to take the derivative with respect to t. And this function models an electric charge measured in coulombs inside a light bulb, t seconds after it's turned on, which would represent the method for finding the instantaneous rate of change of the light bulb's electric charge in coulombs per second at time t is equal to 4. So this function is just talking about time, and the output would be your coulombs. So to find your instantaneous rate of change, we know that we want to find the value of the derivative at t is equal to 4. So we would have to find that q prime of 4. So the best answer choice here in terms of figuring out what the instantaneous rate of change of the light bulb is going to be would be choice B. So when you take a look at example 2 and we talk about units for derivatives, the unit for f prime of x is the unit for f divided by the unit for x. So remember, f is y, and then we have our independent variable, which is x. So remember, when we talk about derivatives, we're talking about a rate of change. It's the change in y over the change in x. So whatever the units are for f of x over x. So that's when we're talking about units when we're dealing with our derivatives. So for example, if t is equal to f of s models the time in hours for a sample of water to evaporate as a function size s is measured in milliliters, what are the units for s? So again, remember, we talk about f prime of s. F prime of s, remember, is our change in y over change in x when we talk about our units. Remember, it's the units of the dependent variable divided by the units of your independent variable. So in this particular case, you're looking at the change in time over the change in s. So again, when you look at the time is measured in hours, s is measured in milliliters. So when you talk about the second derivative's units, the second derivative, so the f double prime of s is going to be hours divided by milliliters and milliliters, or hours over milliliters squared. So the answer choice for example 2 would have to be C, because they're asking you for the units for f double prime of s. So we also can look at derivatives to express information about rate of change in other applied contexts. So we have a function c that gives the cost in dollars to produce a particular product, where c of x is the cost in dollars to produce x units of the product. The function m defined by m of x is equal to c of x plus 1 minus c of x gives the marginal cost in dollars to produce x plus 1 units. Which would be the best estimate for the marginal cost in dollars to produce the 57th product? So really what this question is asking us is, what is the cost of going from the 56th unit to the 57th unit? So now this one right here, we know it can't be A because we're not talking about again, we're talking about the best estimate for the marginal cost in dollars to produce the 57th unit. So again, we're looking at C. C is talking about the rate of change of the cost of the 56th unit. So the only option choice here that we really could be looking at is to talk about the cost going from the 56th unit to the 57th unit would have to be choice C. D would give you the difference in the marginal cost. Okay, so your best choice is going to have to be C.